Hello everyone, myself Snehasish Debnath and I am pursuing my PhD from CSMCRI Bhavnagar as my entry for INYAS Saran's PhD thesis competition 2022. I have chosen one of my PhD work entitled A Unique Water Soluble Probe for Measuring the Cardiac Marker Homocysteine and its Clinical Validation. Homocysteine is a non-essential sulfur-containing amino acids. Normal level of homocysteine in blood plasma is less than 15 micromolar. Now, if in our body, if it exceeds above 100 micromolar due to deficiency of vitamin B, that condition is clinically diagnosed or termed as hyperhomocysteinemia. Now, due to this hyperhomocysteinemia, various fatal diseases can occur, and recently American Heart Association has labeled hyperhomocysteinemia as a marker of cardiovascular diseases. So current scenario of healthcare sector is if we faced or diagnosed with some health problems, we first go to a doctor where he prescribes some basic diagnostic test for which we have to go some particular well equipped diagnostic laboratory, and more importantly this actually whole process is very time consuming and costly, and most importantly follow up is very difficult. So our challenge is to develop a economical homocysteine specific kit which can be useful at low resource settings. So overcoming this challenge, we have developed a simple immunocoumarin ensembled copper complexes which shows high selectivity towards homocysteine. From the pH study, we can see our probe is highly selective at physiological pH, that is 7.4, and from the interference study we can find we can see that we can observe that our probe is highly selective in even in presence of its competitive thiols. So to carry out the real world application of our probe for early diagnostic drive, we have tested our probe in real samples, and surprisingly we have observed that in only in case of cardiac patients we the fluorescence intensity of our probe is quite high. So the advantages of our probe is that no need of trained health worker and minimal sample pretreatment is required. Now validation of our probe with some existing techniques such as HPLC and imported immunoassay test has also been performed, and we have observed that error percentage is below than 5%. Now to conclude, this optical measurement of homocysteine in human samples using the probe and demonstration of its validation with 56 clinical samples are first of its kinds, and therefore this present method demonstrates the feasibility of the development of homocysteine selective diagnostic kit to be suitable for point of care testing. Now my future plan is to encapsulate homocysteine specific probe on the electrode surface in a polymer matrix to develop a point of care miniature device. Thank you.